Welcome students. We have seen definition of sets, representation of sets and types of sets in our earlier video. Now today we will see operations on sets. For example, how we take A union B, how we take A intersection B, difference of sets and all. So we will do operations on sets. This is the topic of our video today. But before starting operations on sets, we'll understand what are Venn diagrams. VENN, Venn diagrams. When he was an English logician, so it's named after Venn, John Venn. What are Venn diagrams? Venn diagrams, as the name suggests, they are diagrams that represent relation between sets. If we have more than one set, or even a single set can also be represented. But when we have a number of sets and we have relation between those sets, that can be very easily and graphically represented by Venn diagrams. How? We take, I have told you what are universal sets. So we take universal sets as rectangles, and all other sets will be its subsets. Those sets be A, B, C, etc. These are represented as circles. And how do we represent it? U, that is the universal set, is represented as a rectangle, and it is a convention to write here U, so that it means this is the universal set. Let this be A, we write it like A, and let this be B. So this is set A, this is set B, and this is the universal set. This shows that A and B are subsets of universal set. That is, they lie within this bigger set. And we write elements by putting dots. Let's say the elements of A are A, B, and C. So we'll write it like this: A, B, C. Let's say B has D and E. So we'll write D and E. Let's say we have another set C which has F and G. So we have C, F and G. So this is how we represent this universal set, its subsets A, B and C in a Venn diagram. Later on when we'll study operations on sets, we'll see how they can be very comfortably represented and explained through Venn diagrams. So by now I think this is clear to you, so that I'll move ahead. Now we'll start our topic, operations on sets. Operation on sets. The first operation is called union. Union of sets. We use U to show union between two sets. Let's say we have one set A which has the elements A, B, C. The second set is B. It has D and E. Now A union B, this is the sign, symbol. A union B is a set. A union B is a set that comprises of all the elements of A and B. That is, all the elements that are present in A or present in B. All those elements are present in A union B. Then this will be A, B, C, D, E. So this is A union B. How do we define it? A union B is the set which has all the elements of A and B. That is, it has elements of A and elements of B. All the elements are present. How will write it? In our set builder form, we'll write it as it has element x such that x belongs to A or x belongs to B. Why or? Because either it belongs to this or it belongs to this, but it certainly belongs to A union B. So this is in set builder form. What is it? You are well aware of. Let's see this example, A union B, where A is ABC and B is DE through Venn diagram. How will this is U, the universal set. Let's say this is A, B, C, and this is B, D, and E. So what is A union B? A union B, we shade the area on the Venn diagram which we are actually talking of. So A union B will be complete these two sets. This is A union B. Okay. Let's say if we had some elements common in them. Let's say A is A, B, C, D and B is C, D and E. Then what? So there are some elements which are common to both A and B. So how we present it? We present it like this. That is, there are certain elements which are overlapping. So A and B is exclusive to A and E is exclusive to E. But C and D, these are overlapping. These are both in A and B. So now this whole area, we'll shade this whole area and this whole area represents A union B. I think this is very clear to you. So this is union of sets. A union B is a set which comprises of elements which are either in A or in B. That is, all the elements of A and B are present in A union B. Okay. Now we'll see certain properties on the operation of union of sets. There are some properties. Let's see there. Let's see the properties. First property is called commutative law. Commutative law. What is it? Commutative law. It says A union B is equal to B union A. This is very logical. Let's understand it again with our same example. A was A, B, C, D and B was C, D and E. Let's see what is A union B. A union B will be A, B, C, D, E, because we know that repetition of elements, it's not necessary to repeat an element. Whether it is given one time or two times, it's the same. So when we take the union, we do not repeat the elements. So this is A union B. What is B union A? B union A. C, D, E and then A, B. But we know that position of an element in the set, whether it's on the first place or in the second place, is immaterial. 1, 2, 3 or 2, 1, 3 both are same when they are elements of a set. So A union B is equal to B union A. Clear? Even in Venn diagram, if you see through Venn diagram, let's say this is A, this is B. This was our A union B. If we take B union A, again this is the same. The shaded area is the same. Therefore, commutative law is A union B is equal to B union A. So commutative law is applicable in case of union of sets. Second property is called the associative law. Associative law. What is associative law? It says A union B union C is equal to A union B union C. Very clear? Let's see an example to understand it. Let A be our familiar A B C D. B is C, D and E, and set C we usually write sets in capital letter. So let C be E, F, G. Okay, this is our A, B, C. Let's say the first thing A union B union C. What will be A union B? I'm writing it here so that later on I can put C also. A union B will be A, B, C, D, E. So this is A, B, C, D, E. And this union C, we have to add this. So E is there, so this will be FG. FG. So A union B union C is A, B, C, D, E, F, G. Now let's say this part. First of all, we will take B union C. What is it? C, D, E, F, G. So we have C, D, E, F, G. And then we take this A union this thing. So A union, so we'll put A, B, C because we have D. C, we also have C. So we'll put A, B, A, B. So both the sets are same. The positions are different, but the sets are same. Therefore, A union B union C is equal to A union B union C. Let's see this in Venn diagram so that I know this must be very clear before you, but let's see in Venn diagram so that you get comfortable with Venn diagrams also. Let's say this is A, this is B, this is C. I'll make two diagrams, okay, and we'll see whether they are same or not. And the second one is A, B, C. A, B, C. So the first A union B. What is A union B? A union B is this one. A union B. So A union B and union C. This union C. So this will be this. Second part. B union C. B union C is this. B union C. And A union B union C. Both are same. So A union B union C is equal to A union B union C. So this is associative law which is applicable on the operation of set. What type of operation? Union of sets. Third property is it's called law of identity element. Law of identity element. Law of identity element. It says? It says A union empty set phi. A union empty set is A, undoubtedly. When you have A and you add an empty set, it will be A only. Fourth is law of U. What is it? U, universal set. What is it? A union universal set is universal set. Very logical. Why? Because let's say this is U and this is A. So if we have A union A, what it will be? This full set. And what is this set? This is U. So these are two properties, very logical properties. Nothing serious about it. You can deduce it logically also. The fifth property is called idempotent law. Idempotent law. It says A union A, what it will be? A union A, let's see. A is ABC, again A is ABC. What will have A union A? ABC, this is repetition, so this will be ABC. And what is it? It is A. So A union A is A. So these are some of the properties of union of sets. I think these are clear before you. The next operation that we'll study is called intersection of sets. Intersection of sets. What is intersection of sets? The symbol is inverted U. So, what is intersection of sets? A intersection B. Let's have two sets, A and B. So, A intersection B is a set of all those elements that belong to both A and B. That is, the elements which are common to A and B. Those, if we have a set which contains those elements which are common in A and B, that is, they belong both to A and to B. That set is called A intersection B. So this is the intersection operation. So how we write in set builder form? X is such that X belongs to A and X belongs to B. If you remember, we had in union of sets we had written or, that is, they belonged either to A or to B. That is, every element both belonging to A and B were present in A union B. But here we have only those elements that are present both in A and B. That is, they are common to A and B. Let's understand this. A is A, B, C, D, and B is A, C, F, G. So what is A intersection B? A intersection B has all those elements that are common in both A and B. Which elements are common? A, B, it's not common. C, it's common. D, no. So only two elements are common in A and B. So A intersection B will be A and C. Okay, and just to make things clear before you, what will be A union B? A union B will contain all the elements that are present in A, that is A, B, C, D, and B. So A and C is repetition, so this will F, G. This is A union B. But what is A intersection B? A and C. Only these two elements are common, that they are present in both in A and B. How will represent it? in Venn diagram? This is universal set. This is A. This is B. A and C was common. B and D was exclusive to A, and here we had F and G. So this area, we will set this area, and this area is the intersection, that is A intersection B. This is how we represent it on the Venn diagram. Clear? Okay, let's take one example so that this is very clear before you. Let's say I'm rubbing all these. Let's say A is given as 1, 2, 3, 4, 5. B is given as 3, 4, 7, 9. So these are two sets. What we have to find? First, we have to find A union B. Second, we have to find A intersection B, and we have to represent them on the Venn diagram. What will be A union B? A union will have all elements of A and B. We'll just remove the repetition. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3 and 4 are common, so we won't repeat it. 7, 9. This is A union B. And A intersection B, those elements which are present in both these. Which are the elements? 1 and 2? No, not present in this. 3, 4, yes, they are present. 3, 4. 5, 7, 9, not present. So 3 and 4 are common to these. So 3 and 4. So this is A union B, this is A intersection B. How we will represent it on Venn diagram? See. Let's say this is A, this is B. 1, 2, 3, 4, 5. 3, 4 is common. So 3, 4 will be written here. 1, 2, 5. And here we had 7, 9 exclusive to this. So this is the representation of Venn diagram, and A union B will be this part. So what we do when we have to show it on Venn diagram, usually what we do, we just don't write the elements, because that will make things very it will be very clumsy. So we present it like this. And what will be intersection? How will represent intersection? Union. This is A, this is B. What were the common elements? 3 and 4. 1, 2, 5. This is 7, this is 9. So this is the representation of sets. And so how will represent A intersection B? This is the part which is common to both A and B. This is A intersection B. So this is A intersection B, and this is A union B. I think you are now very clear with union of sets and intersection of sets. Now we will move to the next part. We saw the properties of union of sets. Now we will see the properties of intersection of sets. The first property in union was commutative law. It still holds true for intersection. We'll write properties of operation on, not union, intersection of sets. Intersection of sets. First property we had seen there, it's applicable here also, commutative law. What was there? A union B was equal to B union A. Here A intersection B is equal to B intersection A. Let's see by Venn diagram. A, B, U. This is A intersection B and this is B intersection A. So the common elements are either from A side or B side. Only few elements are common to both, and which is represented here by the shaded region. So A intersection B is equal to B intersection A. Now we'll see associative law. The second law was associative law. What was it? If you remember, A union B and in bracket union C was equal to A union B union C in bracket. It's same here. Associative law. A intersection B intersection C is equal to A intersection B intersection C. Let me go in some detail for this. Let's say we have A 1, 2, 3, 4, 5, 6. We have B 4, 5, 6, 7, 8, 9. And we have C 5, 6, 7, and then we have 10, 11. This is ABC. Let's take the first part. B intersection C. B intersection C. What is it? B and C. Which are the common elements? 5, 6, 7. See, 5, 6, 7 is common in B and C. So B intersection C is 5, 6, 7. Okay. And then we intersect this with A. A intersection B intersection C. Now, this is B intersection C. Which elements are common? 5, 6, 7. We have only 5 and 6. 7 is not present in A. So 5 and 6. So 7 will get out. So A intersection B intersection C is 5, 6 only. When we have gone through this way. Now we'll see through this way. A intersection B. What is it? A intersection B. 1, 2, 3 is not present here, but we have 4, 5, 6. 4, 5, 6. So this will be 4, 5, 6. Intersection B. Intersection C. Now we'll see 4, 5, 6 and C. C. 4 is not present, but 5 and 6 are present in C. See, 4, 5, 6. 4 is not present here, but 5 and 6 are present. So we'll remove 4. So what it is? 5, 6. So this is equal to this. This is associative law. Third property is, say if we have a set A intersection phi, that is empty set. We have A, there are some elements in it, and phi is empty. What elements will be common in both? It has no elements. So this is phi. It's an empty set. A intersection phi will be an empty set because no element is common between these two. This is called law of phi. Similarly, if we have A intersection U, we have universal set. This is the universal set. And we have A here. What is common between this U and A? Only this is common. This is not common. This is out of A. So what is common? A and U, it's A. So A union U is A. This is called law of U. So this is the third property. We'll now see the fourth property, idempotent law. Idempotent law. In union of sets, we had seen A union A was A. What is A intersection A? Let's say A is 1, 2, 3 and A is 1, 2, 3. So what will be A intersection A? It will have 1, 2, 3. These three elements are common. So this is A. So idempotent law says A intersection A is A. Okay. Finally, we have distributive law here. In the case of intersection of sets, we have distributive law. Distributive law. It says A union, we are talking of intersection. A intersection B union C is A intersection B union A intersection C. That is, this intersection symbol distributes over B and C. A intersection B union A intersection C. This is distributive law. We can see it through Venn diagram. Let's see like this. Let's say this is B, this is C. So B union C is complete. And let's say we have A here. So what was A intersection B union C? It was this. Okay, because B union C was this complete set. And A intersection this complete set is this. Let's see by the second or the RHS right hand side what it will look like. We have these three sets. First of all, let's show the sets B, C, A. I guess you are able to see. So A intersection B. What is A intersection B? This is A intersection B. This is B. This is A. So we have this thing A intersection B. And then it says A intersection C. What is A intersection C? This is C and this is A. So this is A intersection C. And union of these two. That is, we take both. Aren't they same? So A intersection B union C is A intersection B union A intersection C. For starters, those who have just started with this course, I'm giving you one task. Let's say A is 1, 2, 3, 4, 5, 6. B is 3, 4, 5, 6, 7, 8, 9. And C is 5, 6, 11, 12. So these are A, B, C. You do first of all, you take this thing, B union C, A intersection B union C, and then you take this and this. Pause this video, take 5 minutes and see whether LHS is equal to RHS or not. I'll solve it, but you pause this video, take 5 minutes and try to solve this. Try to check this. Okay, I am doing this. I think you must have checked by yourself. What is B union C? B union C will be B union C. 5, 6 is common. All elements are different. 3, 4, 5, 6, 7, 8, 9. And then we have 11, 12. So this is B union C. Now we'll see A intersection B union C. What are the elements common in A and B union C? A, this is this 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. These elements are common in B union C and A. So, other elements will remove. This is A union, A intersection B union C. Let's see second part. A intersection B. What is this? A intersection B is, what are the common elements? 3, 4, 5, 6. This is 3, 4, 5, 6. Second thing, A intersection C. A intersection C. Here is A, here is this. This is 5 and 6. Only 5 and 6 are common. So this is 5 and 6. What if we take union of these two? This, that is A intersection B union A intersection C. 5, 6 is common. So what we get? 3, 4, 5, 6. And we have this also 3, 4, 5, 6. Therefore, this is equal to this, this is equal to this. So through this example, we have verified distributive law. So these were the properties of intersection of sets. When we do this operation, what operation? Intersection on two sets, we have these properties.